Hello and welcome. If you have been following this channel, I started a project on building a risk management system using Excel VBA. This video is about how to quickly and easily code the risk tracker using modular procedure approach. You can watch the intro to this project if you want to understand the motivation behind the risk management application. I also have a demo on the functionalities of the application that you may watch as well. Basically, the application works this way. A risk is identified, and the details of who identified the risk, the product the risk is associated with, and the type of risk and how severe it is, as well as the actions taken on a risk, and when the risk is resolved are recorded. In addition, we want to track the series of severity change an identified risk can go through. To start coding the application, I will encourage you to download the starter workbook using the link in the video description. Unzip the file and then you should find the Excel workbook you need to follow along. However, the concept and approaches we will look at are not limited to this project. My passion is to make VBA user form coding more fun, quick and easy. Please subscribe and like the video when you find it helpful. You may also share so others can benefit. Happy coding and let us start. Open the starter workbook or create your own macro-enabled workbook. We will look at how to set up the worksheet as tables in a database. With this project, storing the data in Excel is enough because it is a simple data collection application. Hence, no need for a standalone database like Microsoft Access or SQL Server. Whenever a new risk is identified, its information will be saved in the issue worksheet. This information includes who identified the risk, the date it was identified, the staff member assigned to manage the risk, and so on. The first row of a worksheet will always be the table header. In other words, it will contain the column names. The remaining rows will be for the data. Please keep this in mind because during coding, when referring to the data a worksheet contains, we will always avoid the first row. How do we distinguish one risk from another? We need what we call a primary key. The issue ID, which is our first column, is the primary key that uniquely identifies a risk issue. When a risk has a severity escalation or de-escalation, that severity change information will be housed in the severity worksheet. We want to know when the escalation occurred and from what level of severity. The severity ID is the primary key for this table to distinguish one severity change from another. Just by looking at the severity worksheet, how do we answer the question, which risk issue had its severity changed? The answer to that question translates into having an issue ID that we saw in the issue table as one of the fields in the severity change table. In database terminology, we will say issue ID is a foreign key in the severity change table. The presence of a foreign key makes the severity table depend on the issue table. After all, before we even escalate or de-escalate the severity of a risk, that risk must first exist in the issue table. This creates a relationship between the issue and severity tables. In our case, a single issue can have its severity change multiple times, so we say it is one-to-many relationship. The helper worksheet is for all the ranges we will use to populate some of the combo boxes in our user form. For instance, we have 4 different contractors with a range name, RNG contractor name. I have already done the range naming for you if you are using the starter workbook. However, to turn this into a named range, select that range and in the address bar, type the name for the range and press enter. Remember to use meaningful names. Just by looking at the name, I can tell that it is a range object because I prefixed it with RNG. I also know it is a range for contractor names because I made that explicit in the name. But why bother storing the values for the combo boxes on a separate worksheet? I am trying to separate the code from the data resources. We do not want to hard code these values. All that we will do is to tell our code to read the values from this worksheet. We can just add or delete a contractor without bothering ourselves about the back-end code. This is a good programming practice you can adopt. It helps in code maintenance. If you remember, the two data entry tables, sheet issue and sheet severity, have unique or primary keys. This is an integer number that we store. The IDs will be initialized at 1 and increased whenever a new record is added. Though we could have relied on the worksheet's row number for this, we want to mimic Microsoft Access primary key generation, where ID number increases even when old records get deleted. This always ensures unique numbers. Deleting or archiving records should not influence a primary key, else we can run into problems. Doing it this way via a named range brings consistency. Let us look at the product worksheet. We are looking at the risk associated with two products, A and B. Each product has associated risk information. For instance, product A can be exposed to financial risk, which is realized from auditing a financial statement when a reporting compliance is not met. This worksheet is going to be a lookup table for the application. When a product is selected, we can specify the category of risk, and based on that information, a list of associated risk type is populated. As soon as we select a risk type, the classification and the levels get populated. This is like a multi-dependent drop-down list, and I will in a moment show you how we can easily get that functionality. I gave these captions or front-end names to the worksheet: issue, severity, product, and helper. You may use any names you like, but if you are serious about building applications, you do not need to code with front-end names. So, let me quickly show you the back-end or code names we will use for the worksheet. Press Alt plus F11 to get to the Visual Basic editor, and click on any of the worksheets in the Project Explorer. Press Ctrl plus R if you cannot find the Project Explorer. The issue worksheet, for instance, has a back-end name that begins with SHT and a front-end caption that appears in a bracket. If you are using the starter workbook, do not worry. I have defined all the back-end names for you. If you are not using the starter workbook or you created your own worksheet, Excel auto-generates back-end names for you in the form sheet followed by a number like sheet 1, sheet 2, and so on. You can set a code name for your worksheet by changing the very first name property in the Properties window. If you cannot see the Properties window, press F4. Why worry about back-end names for the worksheet if we can refer to them by their front-end captions? There are at least two reasons to consider this. First, back-end names are simpler to code with. Instead of specifying the front-end name of a sheet using this workbook collection, you just write the back-end name. Second, people tend to alter the front-end sheet caption unless they are password protected, and this can break your code. But generally, people do not bother about getting to the Visual Basic editor to change the back-end name. This means it is relatively safer to code with back-end names. If you check another worksheet, say severity, you should see the back-end name I have defined for you. Let us insert a new user form. Right-click the project area, go to Insert and click User Form. You should have a user form and see the toolbox open. The toolbox contains all the possible controls like combo box and text box we can use in our user form. If you do not see the toolbox, enable it from the Tools menu up here. Go to the Properties window. We will change the caption to say Risk Management System. I will also change the default code name of the form to FRM Issue Tracker, and then make the form bigger so that it can accommodate all the controls we will place on it. If you are using the Starter Workbook, you should see an extra toolbox tab called Risk Tracker. Select the issue control and put it on the user form. If you do not see the Risk Tracker tab, right-click the tab area of the toolbox, select Import Page, and select risktracker.pag file, which is part of the package you downloaded. However, if you want to design the form from scratch on your own, from the toolbox, go to the Controls tab, click and add the labels, text boxes, combo boxes, and the other controls on the user form and arrange them nicely. When you click on a control, you should see the properties of that control. This combo box or drop-down button here has a code name CBO_IDENT_day, meaning it is a combo box or a drop-down for the day component of the identification date. You can assign any code name you want. The other combo box CBO_IDENT_month is for the month, and CBO_IDENT_year is for the year component of the date. They make up the identification date picker. You may want to familiarize yourself with all the back-end names of the controls because I created them for you. There is a TST description, which is a text box we will type into if we want to describe a risk. We have a command button with a code name CMD add to tracker that, when clicked, will send the data from the form to a worksheet. There is a list box that will help us view our worksheet data. It has a code name LST edit. I have done all the naming of the controls for you, and you can change them if you want. If you are not using the Starter Workbook, you can use any code names for your controls and you should be fine. The take-home is that use intuitive and consistent code names. If you do not want the auto-generated names Excel gives to the controls you place on the form, please take time and familiarize yourself with the code names I have assigned to the controls, because we will need them when we start coding. If you are using the Starter Workbook, I have assigned the accelerator keys and tab ordered the controls for you. Let us run our form for the first time. Click on the green triangle Run command here or press F5 on your keyboard. If you did everything right, you should see the user form launched. Please pause the video or even re-watch to make sure you are okay up to this point. Please subscribe, share, like, and hit the notification bell. Our user form has the controls we need with no functionalities. We only designed the graphical interface of the form. We need to write the VBA code behind the controls. Close the form and let us go back to the user form design view. If you have not heard of class modules in VBA before, you just created one by inserting a user form. User form is a special kind of class module. To make things simpler for you, we will use the user form as if it is not a class module, and rather use modular procedures I have pre-written for you. If you are using the Starter Workbook and investigate the modules object from the project window, you will find module utils. If you do not see it, right-click the project area and import it from the package you downloaded. If you investigate that module, you should find procedures, which is subroutines and functions we need for this video. I have written them for you to facilitate our user form development, and please do not delete them. You can use them in this project or any other project. They will help us quickly build the form as if we are using Excel functions. You will see very shortly that just one line of code can get a lot done. Double-click the user form or select it and press F7 on your keyboard. If the code view appears blank, do not worry, for we have not written any code yet. From the left top drop-down here is a list of all the controls on the form arranged alphabetically, including the user form itself. Find user form and click it. This should insert the user form underscore click subroutine. If you did double-click the user form to get to the code view, you perhaps have the user form underscore click subroutine inserted already. Go to the list of events from the drop-down on your far top right and select Initialize. The user form underscore initialize subroutine handles what we want to read into the computer's memory before the form itself appears on the screen. There are a couple of things we want ready once the form is launched on the screen. For instance, we want our form, especially the date drop-downs, to show the day, month, and year when we run it. We also want the combo boxes to have the items populated so we can select from. We can do all that in the Initialize subroutine. Let us populate the identification date. To achieve this, we write make date CBO all, and I will momentarily explain where this make date CBO all procedure is coming from and what it is doing. Hit the spacebar on your keyboard and you see the arguments the procedure takes. It takes 3 combo boxes as required arguments. The first is the day combo box. If you are not using the starter workbook, remember to use the code name you gave for the day component of the identification date. The second is the month combo box, and the third is for the year. This is to say we want to make a date by populating the day, month, and year combo boxes of the identification date. We also want our date to display the current date of our computer system, so we set the init value argument to true. There are other optional arguments we can set depending on what we want. Another way to write this line of code is to use the call statement as follows. Like calling a subroutine. Any of these two works, but in this tutorial, I will often avoid using the call statement to minimize the amount of typing. Remember, the CBO ident day, CBO ident month, CBO ident year are the code names we gave to our identification date controls. But where is this make date CBO all procedure coming from? If you investigate module utils, it contains procedures, and make date CBO all is one of them. They are part of a VBA class I developed to make building user forms easy and fast. The make date CBO all procedure turns 3 combo boxes into a date picker. Let us go back to the user form and this time run it. We see that the identification date is set to the current date of the computer, and we can specify the day, month, and year. We achieved all that with just a line of code, and that is the approach we will take in building the remaining of our risk management system. We do not have the resolution date, so let us get that populated as well. Get back to the code view. We will use the same make date CBO all procedure. We need the 3 combo boxes that make up the resolution date. The first is CBO reso day, then CBO reso month, and the year part is CBO reso year. These are the code names we gave to the resolution date combo boxes when designing the form, and you can verify that. What we want to do is to allow users to type in the resolution date even if the input is not part of the items in the dropdown. So skip the init value and init post argument by typing comma on your keyboard, and then set the list style argument to false. This means the resolution date will not be restricted to just the items in the combo box. We saw on Sheet Helper some predefined named ranges. There is a subroutine as part of Module Utils that adds the content of a range to a combo box. It is called Add Range to CBO. It takes the range as the first argument, so we give it one of our named range, RNG contractor name. Since it is a named range, remember to keep it in a square bracket so that VBA recognizes it as such. The last required argument is the combo box to populate. This is the code name we gave to that combo box control when designing the form, and you can check it out. We want to populate the contractor name combo box with the values in the contractor range. You do not need to have a named range before using this subroutine. We could have dynamically defined a range in our code and pass it to the Add Range to CBO subroutine. We are using named range because it makes us write just one line of code. There is another subroutine in Module Utils called Make Add Range to CBO. We could have used that instead of the Add Range to CBO. It will define the range for us and add the content to a combo box. We give it the worksheet which has the data and tell it the column containing the data. The contractor names on Sheet Helper are found in column A, so column number is 1, and then we give it the code name of the combo box we want to populate. These two procedures will give us the same result. However, each of the approaches has its peculiar use case. To populate the risk category combo box, we will use the same subroutine, Add Range to CBO. The named range in our helper worksheet is called RNG category, and the combo box we want to populate is CBO category. You perhaps have noticed that it is as if the names are used for the named range only differ from the form control names by their prefix. This is a good practice. It makes coding easy to read and maintain. Let us populate the other combo boxes. You can verify the names I am using for the range by checking out the helper worksheet. Also, you can verify the code names for the combo boxes by looking at the form in Design View, clicking on a control, and inspecting the name property from the Properties window. Realize that in cases I did not name the range, I opted to use the Make Add Range to CBO subroutine. If you did all the steps right, we could run the form again to see if our combo boxes are populated. We have our combo boxes populated with their respective values. That is impressive. We got all that with just few lines of code. However, we have not populated the risk type combo box yet. That field depends on the product type and risk category. For instance, when the product is B and the category is process requirement, then the risk type should have fatigue management process and operator safety process. If a different pair of product and risk category is chosen, then the associated risk type should be populated. Close the form and get back to the design view. Double-click the product type combo box. You should have the change event subroutine. A change event is triggered when the content of a combo box becomes different from before. We are safe using the change event because our values are not going to be typed out but selected from a predefined list. This is how we will think of the problem. If the product type changes, then use its new value and the value of the risk category to get the list of items to be populated in the type combo box. Since we will require the risk category in order for this to work, we will need to exit the change event when there is no value for the category combo box. We already know of a function that populates a combo box with items from a given range, the add range to CBO. What is left is the range that we will supply to this function. I will show you another function that just makes range based on a value the range contains. If the product is B and category is process requirement, we want to get range C5 and C9 as the risk types. We will use makeRangeContains function, which can be found in module utils. The first argument is the worksheet. Next is the column to search. In this case, we want to search through the product type column, which is column A, and so column number is 1. Since the first row of our product sheet is a header, we begin from the second row and look for the product type the user has selected. Using the product column as reference, we want to move right by 1 to the category column and look for the risk category the user has selected. Remember, we need both the product type and risk category in order to get the risk types. Since the product type column is our reference point, this will return a range in the product column, for instance, A5, A9. We offset this by 2 to get to the type column, C5, C9. We can now use our add range to CBO subroutine and ask it to use this range to populate the risk type combo box. Realize that we could have used the risk category column as our reference column instead of the product type column and still get the same result. What you need to know is how to offset from one column to another. We are going to code the change event for the category combo box as well. In that case, if either the category or the product type combo box changes, we can have the risk type populated. We will repeat the same code as the one in the product type change event, but this time we want to make sure the product type combo box is not null when the category combo box changes, and hence we exit the subroutine whenever the product type has no value. The rest of the code stays the same. Let us try that out. We select the product type and then the risk category. The risk type has been populated. When we change, say, the risk category, we have the corresponding risk type. So far, so good. When the risk type is selected, we want the corresponding risk classification and risk level populated. So let us go back to our form and code the type combo box change event. In the change event of the type combo box, first, it should not trigger whenever the type changes to nothing. It must change to something for us to get the associated classification and level values. But what row or range in our product worksheet are we going to read the risk classification and risk level from? We will use our makeRangeContains function as follows. Given the product worksheet and looking through column 1, starting from the second row, if the product type matches the one selected by the user, also look for a match with the risk type the user selected. This will return a single row. Each product type and risk type combination give us a single risk classification and risk level. We will hold this single row or range using the with block and then assign the risk classification value to the classification text box and the risk level value to the level text box. That is all we need to do. The add range to CBO procedure, unless we set the clear CBO argument to false, will clear a combo box before populating it. This clearing will make the type combo box have no value and hence will trigger the change event of the type combo box. That is why we first insist on exiting the subroutine when the type combo box has a null string value. We must also clear the classification and level text boxes when either the category or product type combo box changes. We can set each of them to VB null string using this line of code. Setting controls to null string is a common thing in user form applications, so there is a one-liner subroutine in module utils for that. We can use it as set ctr to null string and give it all the controls we want to set to null string as array. We will do the same thing for the product type change event. Our code looks fine. Let us try this out. Select a product type, then risk category. We choose a risk type, and there we have our risk classification and risk level populated. If we change the risk type, we get the corresponding values for the risk classification and level. We can fill the other data fields on our form. I hope you paid attention to the few lines of code we had to write to get what we want. It will perhaps take someone a lot of code to get to this point, but I have done all the work for you in reusable subroutines and functions. Please subscribe and share for others to benefit. Next is to store this information onto a worksheet when the Add to Tracker command button is clicked. Let me quickly show you how to do that. You can double-click the Add to Tracker command button to get to its click event. We will use a function called WriteToSheet. It takes the worksheet you want the data to be written to as the first argument. In our case, SHT issue. Next is the data as an array. We need to specify the data in the same order as they appear in the header of sheet issue. The first is the issue ID. We stored that as a named range, so we access it with a square bracket. The identification date was split into 3 combo boxes, and we can concatenate them using the ampersand operator. This will give us a valid Excel date. The identified by column is the next. We continue in the same order until we get to the resolution date. Take notice of the underscore used to break the code and continue from the next line. The last thing we need to do is to update our issue ID we stored on the helper worksheet. So we do RNG issue ID equals RNG issue ID plus 1, making sure there will be a new ID for us to get the next time we add a record. We will talk more about this later. We can try our form out. Fill out all the risk information. You can use the tab order or the hotkeys to quickly move from one field to another. When done entering the information, we can click on the Add to Tracker to send the data to the worksheet, and there we see it added to the issue worksheet. You now have a working form that you can input data and write to a worksheet. There is more to add to our application: the best way to export multiple tables, how to edit a record, reset a record, how to validate an entry, how to escalate a severity level, and others. We will look at that in the next video. My aim is to make building user form easy and fun by giving you pre-written procedures you can put together to build any form. If you like what I do, please subscribe, like, comment, and share for others to benefit. Thanks for watching.